Hello, everyone. First of all, thanks everyone for being here. This is literally the last talk of EFCC, so I appreciate everyone sticking around for this. I will be giving a brief intro on Dialectic, who we are, what we do, and more importantly about what we're going to do in the future. So I'll introduce a new protocol that we partnered with that will allow us to take our strategies on chain, and I'll do a little deep dive into the mechanisms around that. So first of all, about Dialectic, we are a DeFi native asset manager. We run 3 different funds. So these funds produce yield on stablecoins, ETH and Bitcoin. Importantly, these are fully on-chain strategies. So the subscriptions into the funds, the redemptions from the funds, and all the positions in the fund are fully on-chain in DeFi. You can think about this as like sophisticated yield farming. And we've been doing this since DeFi summer, so we've been around for close to 5 years now. We deployed in Curve before there was a token and have been around ever since. So the way that the strategies operate is really like broad exposure DeFi yield. How do we find yield? Well, it's really much about getting all the data, understanding where the opportunities are. So we developed an in-house tool called Codex. And what we can do with this is to keep track of everything that's happening on chain. So we scout across all the different EVM chains. We keep track of different positions the different wallet has, and we can independently measure the returns. We can also independently measure the risk. And thereby, we have like a full overview of all the set of investable opportunities in DeFi. And from there, we can really like narrow it down to the opportunities that fit our risk profile. And then from there, we can optimize for best risk-adjusted return. At any point in time, our portfolio has around 50 to 70 positions in each of the fund. This year alone, we deployed over 300 positions in DeFi. So as you can see, these are quite like fast turnaround strategies. The way that we optimize for risk-adjusted return, on the one side, you have the return side. I just talked about that, just like keeping track of everything that's going on, all the fees, all the incentives, everything like that. On the other side, it's really about minimizing the risk. So there's different layers to risk management. We have this multi-layered approach where at the first step, it's really about due diligence. So that means really deeply understanding the protocols that we interact with, understanding all the security assumptions, the trust assumptions. So this goes from like the smart contract risk to the governance risk to the economic mechanism risk. So for example, lending markets have different risk profiles than decentralized exchanges. Unlike lending markets, you have liquidation risk, you have bad debt risk. So we spend a lot of time just doing due diligence on everything that happens in DeFi. So once we kind of like understand what the risk profile of all the different opportunities is, we can size them according to our diversification policy, which really means that like the high risk position have very small allocations, the low risk positions have much bigger allocations. And so we design and we create a portfolio that's optimal in that sense as well. Then once the positions are deployed, we have real-time monitoring on everything that we do. So we work with different security partners. Hypernative, for example, is one of them. And we have full real-time monitoring on all of the positions. And we developed some tooling that allow us to do automated withdrawals. So if ever there is like some risk event on chain, like a tokenized depegging, a like lending market is starting to accrue bad debt, or a smart contract exploit is going on, we can trigger an automated unwind and reduce the risk on the position basically in the next block. So this allows us to be very fast and react very quickly to changes in risk profile of different opportunities. On top of that, we have full portfolio coverage with Nexus Mutual. So Nexus Mutual, many of you may know, they're an insurance provider for DeFi. And we are the first fund that they felt comfortable with to give a full portfolio level cover with insurance. So this insurance covers smart contract exploits, bridge exploits, token depegs, and things like this. So what we're really trying to do here is to give our investors access to all the high yields that DeFi offers, and then at the same time really try to drastically reduce the risk through this multi-layered risk management approach. So What is happening in DeFi right now? I think all of you have been at DFCC last week, so we've seen a lot of the traditional finance, the fintechs starting to come into the space. Our general thesis on DeFi in general is that a lot of the capital will move from being privately managed to professionally managed. So this means that we'll have less and less individuals and small prop shops deploying their assets directly in DeFi, and more will be directed towards professional asset managers like us and like the Morpho curators and many of these types of players who are just like specialized in doing this, who have the experience, who have the risk management practices. And we believe that over time, we'll see more and more of these professionally managed strategies on chain. So the same way that in traditional finance, we have mutual funds and index funds and hedge funds and all these different fund structures that just like do this professionally on behalf of their investors. In DeFi, we also see a similar trend where we have a lot of on-chain vaults. Now we also have tokenized trades. So for example, Athena or Resolve, it's just tokenizing a single basis trade and just making that accessible to everyone. And then we also Morpho and Euler and these different protocols using the curator model, where it's also like the individual investors, the individual users providing liquidity to the vaults, and then having professional risk curators managing these positions on behalf of the users. So we really think this is where the space is going. We believe that this is what DeFi will become. We'll have a lot of these aggregation layers that just take away a lot of the complexity from the end users. So how are we reacting to this changing market structure? So we are partnering with Makina, which is an on-chain asset management protocol. It's a layer of infrastructure that lives on top of DeFi. So this is a smart contract-based system. This is a vault infrastructure for asset managers like us. We were design partners with them, helping them to build a protocol that fits the requirements that we have. And I'll go a bit more in depth now on like how this works to kind of give a better understanding of what's possible and what we will be doing with this technology. So some of the features, first of all, of the Makina infrastructure is that it's fully non-custodial. So we have seen a lot of vaults in the space that is basically just a 4626 wrapper around the Gnosis safe. So there's a lot of limitations that come with that. There's increased trust assumptions. So from the get-go, Makina was designed to limit those trust assumptions and to make a system that's much more resilient. It allows for on-chain risk controls. As you saw, we really care about risk. We take risk very seriously. So it was very important for us that the infrastructure that we run our strategies on can meet our standards when it comes to risk management. Also in regards to the automation systems that I mentioned with real-time monitoring and emergency withdrawals, the underlying technology stack needs to be able to do atomic execution. So whenever there is a risk event, we want to be out of the positions as quickly as possible. So this is where like having atomic execution and being able to fully unwind a position in a single transaction is really, really important. With atomic execution, we also get flash loan support for free. If you're able to like fully execute an action in one transaction, you can just take a flash loan before executing it and then repay the flash loan at the end. This is really important because it enables strategies like loop positions, arbitrage between decentralized exchanges and things like this. The infrastructure also needs to be fully cross-chain. I mean, we've been seeing a great expansion of layer 2s. There's so many new chains coming up. All of these different chains need to bootstrap their liquidity. They usually do that by providing very high incentives for people to bring their liquidity. So for us as liquidity providers, it's often crucial to be very early on these ecosystems and to be able to deploy your capital as soon as possible. So we needed an infrastructure that allows us to like deploy our capital on different chains very, very quickly. The other thing kind of on a similar line is the speed of integration. It's very difficult to interact with DeFi. Every protocol has different standards. Every protocol has different ways to interact with it. The traditional model is to write custom smart contract adapters for each protocol. That is a lot of overhead, and it delays the time to deployment, like from when our scouting system finds the opportunities to when we can deploy the opportunities. We need to be really quick in that. So what Makina allows us to do, and this is where I will spend a lot more time on the presentation, is really like explaining how the interoperability with external DeFi protocols work, because I think that's just a crucial point of being able to be agile and being able to like really get the alpha while it's there before the opportunities get diluted. So Dialectic will be operating its strategies on Makina on day one. There will be potentially other operators together with us. But I think this is will really be the guinea pigs for this new technology. So as I was saying, we kind of need to like understand the architecture. So I have here like the two models. The legacy model is this kind of like the users, they provide liquidity or they deploy their capital into one vault. And then the vault has a lot of different adapters to the external protocol. Each one of these adapters is its own Solidity smart contract. And they all need to be audited, and it takes like a couple of weeks of turnaround to get these up. And oftentimes it's like the opportunities are not that long living. So the way that Makina works is that we have a concept called the Caliber. The Caliber is a single smart contract that's deployed once, and then this Caliber takes off-chain execution instructions to interact with the external protocol. So there's no more need for writing custom adapters to each protocol. There's a single smart contract which implements an on-chain virtual machine, and then we can send off-chain instructions to this virtual machine to be executed. So this gives us like a lot more agility. It also limits the attack surface because there's no stateful smart contracts. Everything is executed atomically. And also like there's less of an auditing need for these. So the way that the cross-chain mechanism works is through a hub and spoke model. So the users will always interact with a contract that we call the machine. The machine lives on the hub chain. You can think as mainnet being the hub chain for most cases. And then we deploy these execution engines on all the different chains, and the assets can be bridged from the smart contract on the machine, on the hub chain, onto these other smart contracts that live on the spoke chains. And then from there, the liquidity can be deployed into the DeFi positions. This makes the system like very closed in scope. So the assets can only bridge between the smart contracts of the protocol. They can't be bridged to external addresses. So it's similar to the child safes. So Gnosis Safe now has this concept of deploying a safe on one chain and then deploying these sub-safes on other chain. It's a similar architecture to that. I think like very importantly, the way that we treat deployments in DeFi is that we have an abstraction layer that goes on top of the actual transactions. So we have this concept of a position. So a position is a position of liquidity deployed in a DeFi protocol. The way that positions are opened is through what we call instructions, and instructions are atomic bundles of transactions. And I'll go a bit more into that. But what this allows us to do is that we can like define very concrete ways in which the operator interacts with external DeFi protocols. Everything is a position. Every position needs to have an instruction to be opened, an instruction to be closed, an instruction to be accounted. So we use the same mechanism to open positions, close positions, and account for positions. So how does an instruction look? So an instruction is basically a transaction that is sent from the operator to the on-chain vault. The instruction is executed atomically. Every instruction has a position ID, which uniquely identifies the position that's being managed. It has an action type. So this could be a management instruction or an accounting instruction. And then it has a wayroll script. I will go a bit more into wayroll and how that works. But that is basically where the logic of the executable sits. We also pass in a Merkle proof because every instruction needs to be pre-approved. It needs to be included in a Merkle tree. So then when the operator executes the instruction, a Merkle proof is passed. The smart contract can verify the Merkle proof, make sure that the instruction that's being executed was pre-approved. And if that is good, it can be executed. We also pass in a list of affected tokens. This is crucial because we need to do slippage checks. So every smart contract, every Caliber can do generalized slippage checks by checking what the balances of the tokens were before the instruction is executed, what the balances are after the instruction is executed, and then it can verify what the delta is and make sure that no funds were lost in that operation. So this really adds a lot of safety. This allows operators to act in a much more automated way because even if there is some bug in the system or if it's a fat finger from a manual execution, the smart contract still verifies that no funds are lost when executing these instructions. So how are these instructions constructed? So we designed a DSL, so a domain-specific language. It's more of a YAML file, actually. But this is a human-readable piece of code, in some sense, that can then be translated into an instruction that's executed by the virtual machine. So there's kind of three components. So in this example, we want to approve a token and supply it as collateral to Aave. So this is two transactions that need to be executed. We need to approve a token, and then we need to call the Aave contract with the supply function to actually deposit the token into the smart contract. So there's kind of three sets of keywords. So we have the constants. In this case, it's the Aave pool. So a constant is something that never changes. The address of the Aave contract will always be the same. So this is something that can be hard-coded in the instruction, and it will be the same for all Aave pools, for all tokens, and everything like that. We also have variables. Now, variables are specific to the strategy. So depending on whether you want to supply wrapped ETH or you want to supply USDC, these addresses change. So these are things that are specific to the strategy that's being run. And then we have inputs. And inputs are really the things that change on a function call by function call basis. So once we define we want to interact with this Aave contract, we want to approve this token, then every time the instruction is executed, we just need to define what the amount is that needs to be supplied to Aave. And so all constants, all variables are always included in the Merkle root. So once the Merkle tree is approved, the operator cannot change the Aave contract. The operator cannot change the token that they're approving. In the case of Aave, there's also a parameter which is on behalf of, which is where the supply is credited to. So there's also not something that the operator should have discretion to change. Like if the operator is deploying the liquidity from a vault, the collateral should be credited to this vault. So these are all functions, function parameters that are included in the Merkle tree. So these cannot be changed anymore once the Merkle tree is approved. So the only thing in this case that the operator has discretion over is how much is deployed. So the only input in this case is the amount. So this means that once this is approved in the Merkle tree, the only thing that the operator can do is to interact with this contract with exactly this parameter, and they can only change the amount. So this really limits the set of executable things. It really limits the degrees of freedom that the operator has, and really allows the system to really reduce the trust assumptions, because it's very granular ability to fix things. This kind of domain-specific language, these blueprints implement standard solidity types, so they're very easy to implement. And as you can see here, there's kind of the two function calls. So there's the first call, which is the approve. It has a target where the function call is directed to. In this case, it's the address of the token. And then the function signature, which is approve. It takes an address and a number. The address is the Aave pool. We always only want to be able to approve the Aave pool. We shouldn't be able to approve random contracts. And then the amount is the one input that the operator has discretion over. And then once the approval is done, the virtual machine can go and execute the second call, which is the supply. So here the target is the Aave pool, and then the parameters are the two variables, so the token that needs to be supplied, the input amount, as well as the on behalf of, which is where the supply is credited. So then what happens is that once this is defined, this is also human readable, so it's very easy to check what's going on in here. This gets transpiled into an instruction. So in this case, we instantiated the instruction with the wrapped ETH address. So what we are now, so we had this blueprint, which is generalized to all interactions with Aave. Now we have an instance of this blueprint, which is specific to wrapped ETH as the asset that's being deposited. So as you can see, we have some of these same variables. So we have the position ID, we have a dead flag that basically just says, is this position a dead or not? If it's a dead, it needs to be accounted for as a negative position. We have the list of affected token, wrapped ETH, so we can check what is our wrapped ETH balance. Then we supply some wrapped ETH to Aave. Then we can check what's our wrapped ETH balance after, and we can make sure that the amount we supplied is not too different from the amount that we had before. And then we have these way-roll commands, which are basically the machine executable instructions that we send to the virtual machine. And we can see the two function calls here that I had before. So first there's an approve, and then there is a supply. So this is the command to execute the approve. This is the command to execute the supply. And then here we have the parameters that we had. And as you can see, all of these are hard-coded addresses. So when this instruction is sent to the smart contract, these will be included in the hash that we verify against the Merkle tree to make sure that these can be changed. And then this kind of random string of numbers, this can be overwritten. And then this will pass the verification step. If you're not familiar with way-roll, you can read up on that. It's super cool technology. It's an on-chain scripting language that kind of makes all of this possible. It's fully open source. It's maybe not super well documented, but you can look at the repo and probably figure it out. So basically, what happens is that once we have all of these instructions together, so now we had like one instruction to provide liquidity to Aave. On the supply side, we can just have a giant registry of all the protocol interactions that we want. We put them all in a Merkle tree. So we pre-approve all the different things that the operator can do to run the strategies. Then all these instructions are sent to the on-chain virtual machine. So this is the Makina VM. Which lives inside of the Calibre. So if you remember, the Calibre is like the local execution environment that is deployed on all of the chains. And basically what happens is that this instruction is verified for its integrity. So all the parameters are checked against the Merkle tree. The smart contract makes sure that only things get executed that were pre-approved. Then it executes the instruction. So that's where like the tokens move out of the vault into the protocol, or the other way around in case we are decreasing a position. And then afterwards, we can do a slippage check to make sure that not too much value was lost during that interaction. And the thing that we can also do is to take a flash loan basically before the execute step. So we can just like have an instruction that calls a Morpho contract, takes a flash loan, executes a loop position, for example. So you would take the assets in the flash loan from Morpho. You would buy a PT token on Pendle, put it up as collateral on Morpho, and then borrow against that position to repay the flash loan. And in one transaction, you opened up a leveraged position. So I will quickly show a video of a demo to kind of like make this a bit more tangible. So this is a command line tool that we built. This is like version 0.1. But it will kind of show how, from an operator point of view, all of this will be done. So basically, we like need to select the strategy. So in this case, we have like a machine. This is Makina test ETH. We are selecting to execute things on base. So this machine has like the ability to open positions on mainnet and base. In this case, we are operating on base. So then the command line gives us all of these different options. So the first thing that we do is to check what positions we have open. So in this case, the Calibre has 3 positions. There is base ETH supplied on Morpho. There is some EUSD borrowed on Morpho. As you can see, this is our negative position because it's dead. And then this EUSD has been deposited into Tokamak. And as you can see, like these numbers are very similar. Because it's just like taking the debt against Morpho, deploying it somewhere else. As long as the tokamak position has a higher APR than the borrow cost on Morpho, there is a positive spread on this position. So we can kind of like look at this on dbank. So this is actually like deployed on mainnet right now in kind of a private test instance. So we have all the data on mainnet. You can see that we have these 3 tokens. So base ETH is an index of these 3 tokens that are supplied. And then we have the borrow position. And then down here, we have the borrow position supplied on the tokamak. So then I think what we will do now is to manage a position. So what we will do is to interact with Morpho. Here we have a list of 3 different actions that can be executed on the Morpho smart contract. We have like add collateral, borrow asset, repay asset, and withdraw collateral. So these are the 4 actions that an operator needs to interact with Morpho. What we will do is that we will borrow some more USD. So in this case, we are borrowing 20 more USD. The command line simulates the instruction. So this is kind of like the raw call data that was generated in the CLI. It simulates the interaction with the Caliber to kind of like display what assets are being moved. In this case, there is an inflow of 20 USD into the Caliber, which is what we expect. So we can approve this. Now it's being sent to Base. Once this transaction is confirmed, we will be able to see it show up on DBank. Also, after a transaction is confirmed, we just print all the balances again. So in this case, you see that now we have 20 USD in the wallet, or in the Caliber in this case. This will also show up on DBank once it's refreshed. So all of this happens in real time. And as you, like instead of traditionally you would go Morpho, you would click all the buttons, sign like multiple transaction. Here it's one command, it's executed in a single transaction. And we borrowed the USD. So what we need to do now is to swap some of this USD to USDC. So we can also execute swaps out of the Caliber. This is done through different DEX aggregators. So again, there's like all the command line tooling to swap one token to the other. We can set the slippage. It then requests a quote from Odos in this case. And then if we like the quote, it gets simulated. So you can see that we have some outflows. So 10 USD are going out. Pretty much 10 USDC are coming in, basically minus the transaction fee. This looks good, so we can execute. And this will now execute the swap. And as you can see now, the USD balance went down and the USDC balance went up because we executed the swap. There's also slippage checks on all of these swaps. So even if like the DEX aggregator is compromised or like the call data that's being executed is malicious, there is still an external slippage check inside of the Caliber just for like an extra layer of safety. So now we can see this updating on DBank as well. It will just like show the new position. Then we can deploy a new position. So this is a position that wasn't on the Caliber before. This is deploying into Curve. So this is the CRV USD pool on Curve. So what we will do here is a single-sided deposit where we just deposit the 10 USD that we have left. And in this case, what we will do is actually deploy the Curve position and then receive the LP token from Curve, approve it, and stake it into the Curve gauges. So you'll see now here in the simulation, we have the outflows, we have the USD going into the pool. We are minting the LP token of the pool. Then there's like inside of the instruction, there's like a very big instruction. There's like many steps in this. So then the LP token needs to be approved. And then we have the outflow of the LP token going into the gauge, and then the gauge mints us the LP token. So this all looks good. We can just approve this. This is now being sent, and then when we go over to DBank, you'll be able to see the position on Curve being staked in the gauge. So also if you do this manually, this is at least like 5 or 6 transactions that you would have to execute and sign and everything. Which if you do this stuff from a MetaMask hot wallet is not so bad. If you operate a professional fund like us, there's multi-sigs and every transaction needs to be approved and checked by multiple people. So deploying these like multi-step position takes quite some time if you do it manually. Here it's just like an execution in the command line. So now that we opened the position on Curve, we still have 10 USDC left, so these will just be deployed into Tokamak. So this is just now executing the second deposit. In the case of Tokamak, it's also the USDC is deployed into the Tokamak vault. We get back the Tokamak USD. You can see here, this is the inflow that is being minted. And then this LP token is staked in the Tokamak contract. So this is also a approving the USDC, deploying the USDC in token mark, receiving the LP token back, approving the LP token, staking the LP token into the staking contract, and all of this is executed in a single action fully atomically. So this also looks good. So we can just like approve this, transaction is being sent, and then we quickly go back to the bank and look at that position there. So as you can see, so this is also just like displaying the position again. So now as you can see, there's an extra position here, which is the one that we just deployed. Cool. So this was a little demo. I hope now everything is a bit more clear and tangible. So why did we at Dialectic decide to use this technology stack over other technology stacks? I mean, as you saw, like it's very usable, super user-friendly from a user perspective. We have full EVM compatibility to any chain. We have the full atomic execution. It's fully non-custodial, which is also very important from like trust assumption basis. We have the infinite composability, and there's some really cool tooling. Like the CLI is the first kind of like operator-facing tooling that Makina will provide, but it looks like we'll also get an API, we'll get an SDK to run automated strategies and these sorts of things. So what will we be doing with this? So we will launch basically 3 products. So these are all on-chain yield indexes. An example here would be the Dialectic USD yield index. So this will be just like broad exposure, stablecoin deployments across many different chains, across many different protocols, many different underlying assets. So we can really have good diversification, good risk management. And also all these strategies will of course be tokenized. So there will be a yield-bearing token that anyone can buy on decentralized exchanges. It's fully composable. You can put this on lending market, you can loop it, and all these types of things. But we will also have our other 3 strategies. So there won't just be USD yield index, there will also be an ETH yield index and a Bitcoin yield index. And it's all very similar strategies. So these will all be available on Ethereum mainnet, as well as Inc. So Inc is the Kraken L2. It's one of our great partners. They've been very supportive. And it's all like running on Wormhole, which is our auto launch partner. So these tokens will all be tradable on decentralized exchanges. Anyone can just go on CowSwap or wherever and buy these tokens, and these will just be yield-bearing tokens that go up and accrue the yield, and then they can be redeemed against the underlying with no KYC required on the decentralized exchanges. So what are the features of these strategies? So we'll have the same real-time monitoring that we have for emergency withdrawals. So any position that's deployed will be monitored in real time with Hypernative to get real-time alerting on risk events. Through the atomic unwind, we will be able to close all of these positions very quickly. We can also just like optimize all the harvesting. Similarly, we can just like look at all the different incentive tokens that are being paid out and just compound those in an efficient way. Makina will also offer a security umbrella. So this is very similar to what Aave has, where you have a ability to underwrite the risk of the strategy. So some users who have a higher risk tolerance can stake their LP tokens in the umbrella contract. And then in case of losses, those positions will be slashed. But what that will do is that anyone who is not in the umbrella will have cap downside. Because there's this like native insurance mechanism. So this is really kind of reproducing the Nexus Mutual insurance that we have on the funds. And then lastly, we can enforce risk policies. I mean, all the positions will be on-chain and auditable anyways. But the smart contracts also allow to set exposure caps. So we can say, as an operator, that we commit to not allocate more than whatever percentage of the portfolio on any single protocol or on any single chain or on any single asset. And then this is an on-chain enforced risk policy that can provide diversification to the user and make it very transparent. I don't have a thank you slide, but thank you everyone for listening. And I think we have 2 more minutes for questions.
You can raise your hands if somebody has questions. give you the mic.
What will be the fees on the strategies?
TBD. So like the strategies can take management fee and performance fees. It kind of depends on the yield and how much liquidity we have. It's gonna be like 110, 220, somewhere in that range. Then those fees are split between the operator and the protocol. So Makina as a protocol takes a fee for the infrastructure. So all fees that are generated will go in large part to the operator and then a smaller part to the protocol.
Hey, thank you for the great presentation. Quick question on the CLI. So I guess it is going to be public, right? Like, we're also going to be able to use it as DeFi users?
If you run your own strategy, yes. Like the CLI is specific to a strategy. In this case, we had like this Makina test ETH strategy deployed. The CLI is connected to that specific vault and that specific strategy. If you run one to like as a personal user, just deploy your own private strategy where it's only you, you'll have the CLI and you can just rebalance your portfolio using that.
Understood. Then maybe, yeah, maybe my question makes no sense, but I saw that there was no like strategy health breakdown in the CLI directly. Like, you know, you were borrowing and we couldn't see the health of the strategy. So I was wondering, like, is that something that's gonna happen and appear at some point? Or?
Yes, I mean, all feature requests welcome. I mean, as said, this is like a very early version. This is just like trying to get stuff up and running on mainnet. But we'll work closely with the Makina team over the next couple of months to bring our own feature requests. I think the Makina team will work with other operators to get their feature requests, so we can just add all of these things and make sure that it like works for us and everyone else.
All right, thank you very much.
We'll take the last question, yeah.
Yeah, I had a question for the vault strategies. Deposits, are they taken in a single asset, multi-asset, and for withdrawals, the same thing?
Yes. So every machine defines an accounting asset. That's the asset in which the share price is denominated in, and that's the asset in which all positions are denominated in. And that's also the asset that users deposit and redeem from the vault. Then there's also a thing called base tokens. So the base tokens are the assets in the strategy that are priceable through oracles. So like if the accounting token is USDC, the user deposits USDC, but then the operator maybe wants to deploy a position denominated in USDT. So in that case, USDT needs to be enabled as a base asset, which requires there to be a price feed from an oracle that prices USDT against USDC, so that all the accounting can run on chain.
Sorry, since you mentioned oracles. So sometimes, you know, you might have to price based on something else that requires multiple oracles, so composing oracles. How are you guys going to solve that? Are you looking at stuff like Euler oracle systems or anything like that?
Yes, so the oracle system is, I think, based on Morphos registry, where you can do multi-step pricing. So if you like need to jump, like do 2 jumps to get to the asset, that's possible.
Okay, thanks again for the presentation.
Thank you so much.